Hi everyone. In this video, we will start to develop a shared language of what is chemistry and matter and kind of touch base on some applications that you may see in your everyday lives. So for example, a lot of students can get excited about chemistry when they watch a TV show or a movie that involves forensics. And in fact, forensic scientists that work in the crime laboratories have to have an extensive knowledge of chemistry so they can analyze bodily fluids and tissue samples that are collected by the crime scene investigators to help solve whatever mystery they're trying to solve. Another example of where chemistry is in our everyday lives is the development of pharmaceutical drugs that are used to maybe help treat or prevent disease. And so every day, medicinal chemists are working in the laboratories to test new product and develop pharmaceuticals. Now, the learning goal for this section here is for us to define what chemistry is and to be able to distinguish what substances are chemicals. So it's important that whenever you're taking any class or any new field, such as chemistry, that we developed a shared vocabulary. So I will be going through some definitions throughout these lecture videos. And like I said, that helps us develop a shared vocabulary with one another. So what is chemistry? Well, chemistry is the study of composition, structure, properties, and reactions of matter. So throughout the course together, you will learn what composition means, like maybe what a molecule is made of, or what's the difference between an element and a molecule. We will definitely discuss structure. So you'll get to learn how to make molecules and draw them out and even see them in 3D, which is pretty cool. And if we understand a molecule structure, then we can understand its behavior or its properties. So for example, properties could be like boiling point or melting point, etc. And definitely we will learn some chemical reactions. And just so you know, like chemistry is not something that just happens in the laboratory. It happens all around you every single day. So I'm hoping by taking my course, you will start to look at your world and everything around you a bit differently. So for example, if you ever need to take an antacid, if you have heartburn, you may use one of these tablets. And if you put these tablets in water, you'll notice it begins to fizz. And basically what's happening is that the antacid is undergoing a chemical reaction. Now, this is just an example of the antacid in water, but if you take the antacid, then it's also undergoing a chemical reaction in your body to help reduce the acid reflux that is causing the heartburn. So we've defined what chemistry is, but what is matter? Well, matter is another word for all substances that make up our world. Everything's made of matter. We can touch it, it's tangible. So for example, those antacid tablets we were looking at on the previous slide, they're made of matter, and we'll discuss that deeply in the future lecture recordings, what they're made of. Water is matter. So water can be a solid, it can be a liquid like water, and water is a liquid at room temperature. Glass is matter, and air is matter. So everything around us is matter, and it can be in different states of matter, such as solids, liquids, and gases. So we'll dive in deeper, looking at the different states of matter in a later video. Now, chemicals are substances that have the same composition and properties wherever they're found. So for example, water is a chemical, and we will discuss that water's chemical formula is H2O, right? So it has 2 hydrogen atoms and 1 oxygen atom to make up that molecule. And just so you know, a lot of the stuff that you use every single day are substances that were made by chemists. And so a good example is toothpaste. And there's so many different brands of toothpaste out there. And you can look on the back and see what the key ingredients are. And each ingredient is there for a purpose. Remember that based on the structure of the chemical or of the substance of matter that we're looking at, it's going to have a specific property, a specific use. Now, something that's interesting is you'll notice training toothpaste. And if any of you have had children or have worked with children at all, especially toddlers, they tend to use the training toothpaste. And the reason why is because it does not have fluoride in it. We'll learn a lot about fluoride. But basically for right now, fluoride's really good for the enamel for our teeth. Helps to kind of protect our enamel, and that helps to prevent cavities from happening if we have good enamel there. But with little ones, they tend to struggle with maybe not, they want to swallow the toothpaste. Maybe it tastes really good instead of spitting it out, but that's not really good to ingest. And so there's a reason why there's training toothpaste for the little ones versus the stuff that adults would use or older kids could use, because we know we have to spit that toothpaste out and we don't want to swallow that. So toothpaste is a combination of many chemicals. Here are just some examples of chemicals that are commonly found in toothpaste. So for example, you always have to think, well, what's the purpose of toothpaste? Primarily to remove plaque, hopefully to prevent gum disease and cavities, those sorts of things. So calcium carbonate is used as an abrasive to remove plaque. And we will learn later on that that's an example of an ionic compound. Sorbitol is in there. It helps to prevent loss of water and hardening of the toothpaste, so to keep it the right consistency in that pasty form, it doesn't dry out. Titanium dioxide, you're going to see titanium dioxide in a lot of products you use every single day, but it is in toothpaste, and it's used to make things white and opaque. And you can see this chemical here, triclosan, is used to inhibit bacteria that causes plaque and gum disease. So everything in the products that you use has a purpose, right? And so it is my hope to get you excited about chemistry throughout our time together, so that you can, like I said, look at your world a little bit differently. The products that you use, maybe the food that you're eating, or maybe you're out in the field and you're working with chemicals as an EMT, for example, or medications as a nurse, all that good stuff. I want you to start thinking about, what is everything made of around your world? And that goes with the kitchen. So many of you throughout this course will hear that I have a love for cooking. I love to bake. Baking essentially is a science. So even in the kitchen, there's chemicals everywhere. So some examples you can see, just even like what your refrigerator is made of. It's made of a metal alloy. An alloy, we'll learn, is just a mixture of chemicals, a mixture of metals specifically. The bags or any kind of things that you use that are plastic, that's usually made of polymers. If you have a gas stove, natural gas is a chemical. And the fruits that are grown are also made of chemicals, but if they're non-organic, then they may have been grown with fertilizers and with pesticides. So there may be chemicals there. Even your water is chemically treated as well at the water district. And then once again, I've mentioned glass before. Glass is made of silicon dioxide. It's actually an amorphous material. So we'll discuss some of these in a little bit more detail in the later videos. But for right now, I'd love for us to do a study check. So take a moment. Which of the following, and it can be more than one, contains chemicals? And so I'd love for you, anytime we do study checks together, to pause the video, to try to do it on your own, and then you can come check your work with me. All right, hopefully you've had a chance to do that. So sunlight, did you say it was a chemical or not? Good. Hopefully you said it's not a chemical. It's actually a type of energy, and we will cover energy in a later lecture video. Fruit, we already kind of discussed that one in the previous slide, is a chemical, or it contains chemicals. Just what it's made of in general, like you have sugars in there, so carbohydrates, you have some fiber in there. There's so many different chemicals that make up fruit beyond what we covered on the previous slide of, fertilizers or pesticides if they're used to grow your fruit. Milk, hopefully you said yes, it contains chemicals. And so there's different fats in there, protein and sugars. There's all sorts of things in fruit. Lactose, as an example. So that does contain chemicals. And breakfast cereal also contains chemicals. And some breakfast cereals fortified, which means it's fortified with different minerals that we may be deficient in our diet. For example, iron. There's a lot of iron-rich or iron-fortified cereals, or vitamin B12 also. Some of the breakfast cereals are fortified with those different nutrients that our body needs to function. And so once again, make sure by the end of this video, you feel confident knowing the definition of chemistry, of matter, and also being able to identify if a substance contains chemicals or not, and be able to define those definitions in your own words, as opposed to just memorizing it. So being able to describe it in your own words. And also I encourage you to look at the different foods that you're eating, look at the nutrients that are in there, or skincare or makeup or whatever it is that you use throughout your day, and see what types of chemicals are there. And you can always search on the internet a certain chemical and find its key properties. And if you ever have any questions, feel free to email me. For example, a lot of students like to email me about cleaning products, what are the best type of cleaning products or what not to mix together. So I'm more than happy to have those conversations with you.